Hello, everybody. It's Paul here again. And now, in this FAST tutorial, we are going to talk about creating a mission profile, but a hard-coded one. So in FAST, the user can create a parametric mission profile, but we're going to start with a hard-coded one just so you can get a feel for what it looks like without seeing too many variable names. And then in the next video, we'll talk about creating a parametric one. But anyway, let's get started here. So the first thing I'm going to do is I'm going to open up FAST, and I'm going to open up a mission profile that's for a regional jet. So I have regional jet mission 02 open up here. And if you're looking to see where I got this from, it came from the mission profiles package, which is where we keep all of our mission profiles shipped with FAST. And then right down here, regional jet mission 02. So you'll notice that all of the function files in the mission profiles package, just like all the other functions in FAST, have a similar header. The function call, who wrote it, when it was written, a description of the function, and the inputs and outputs. For the mission profiles, there's only one input, the aircraft structure, which all of the mission profile information gets appended to. And then we return that structure in order for FAST to fly the mission that you prescribe. Now, one thing I like to do in the documentation for any mission profile is provide a little bit of ASCII art. And this is just a little drawing using the characters on the keyboard to show what the mission profile is going to look like. Now, some people may think this is silly, but I find it useful because it conveys a lot of information to somebody who may be seeing your code for the first time before they ever look at any code. They know exactly what segments you're going to need to create this mission before even scrolling down to see the details. So I think it's very useful. Feel free to do what you would like. Before we get into reviewing all of the inputs required for the mission, I do want to remind you that every package has a README file. So here is the README for the mission profiles package. And you will see that it contains a brief summary of what's in the package. And then we provide a written tutorial of how to build up a mission profile. And that's what I'll be going through in this video. You'll also notice that we put some helpful tips at the end. So definitely give it a read, even if you're watching this video. So now we have talked about the function header. We've talked about where you can get additional documentation. Let's get into seeing what the actual mission profile specification looks like. So you'll notice from my ASCII art here, I'm going to fly a design mission of 2,150 nautical miles. And then I'm going to fly a 45-minute loiter, which I'm treating as my reserve mission in this case. So the first thing you need to do before you prescribe your mission segments is prescribe the mission targets, or the goal you're trying to achieve in each segment. And there are two different types of targets you can have in FAST. One of them is distance-based, which we specify with the string dist, or a time-based target, which you specify by the string time. So in this case, we have a 2,150 nautical mile range to fly, so that's a distance-based target. And then the reserve mission is a 45-minute loiter, so that is a time-based one. So I put a distance target type and a time target type in that order. And then up top, I put in the values of the targets. So in this case, I'm flying a 2,150 nautical mile mission. And again, remember, all of the inputs to FAST need to be in metric units. So make sure to convert from nautical miles to meters using the unit conversion package that we supply. And then for the time-based targets, you can leave those in number of minutes. So we'll leave that as 45. And you'll notice that both of these are column vectors. So please make sure to keep that formatting consistent when you're creating your own. Now that we've defined the targets, we can start looking at the mission segments themselves. So before we start reviewing this, let me scroll back up to the ASCII art for a second. So you'll see here, I have a takeoff segment, followed by a climb segment, cruise, descent, and then we have a little approach, climb, cruise, descent, and land. And that is pretty much what we see in the definition of the mission segments, except I lumped the descent and approach together into one segment. So we have our takeoff, our climb, our cruise, our descent. That makes up the design mission. That's the 2,150 nautical mile mission we're flying. And then the reserve mission has its own climb, cruise, descent, and then we land. So after you prescribe the segments, the next thing you're going to do is prescribe a mission ID to each segment. And that way we know which segments are in which part of the mission. So the takeoff, climb, cruise, descent all have a 1, which means that the distances the aircraft flies in those segments gets accounted for in the 2,150 nautical mile mission. And then all of the distances flown during climb, cruise, descent, and landing account for the 45-minute loiter. So what we're actually doing in FAST is we're iterating over the length of these cruise segments to match the mission target that the user specifies. So now that we've defined the segments and we know which segments belong to which mission, we can start to define the boundary conditions of each of those segments. And the big ones we're going to talk about are the beginning and ending altitudes and the beginning and ending velocities. So for all of the altitudes, alt-beg is the altitude at the beginning of the segment or the initial altitude, and alt-end is the ending altitude or final altitude for that segment. So you can see in takeoff that we are just flying at sea level. And then during climb, we climb from 0 to 35,000 feet. We cruise at 35,000 feet. We descend down to 3,000 feet for our approach, but then we're going to do a loiter. So we'll climb back up to 5,000 feet, cruise at 5,000 feet for that loiter, descend to sea level, and land. And again, notice how I've converted my units from feet to meters such that all the inputs are in metric. So that is all I need to do to define the altitudes. The next thing I could optionally do is define a climb rate. Now, for all of the segments that you aren't climbing or descending, you can leave this as NAN. So any takeoff, cruise, and landing, feel free to keep the climb rate as NAN. For climb and descent, the user can optionally prescribe a fixed climb rate. If you prescribe a fixed climb rate, FAST will honor that climb rate and adjust your airspeed as needed. If you don't prescribe a climb rate, FAST will compute one based on the energy-based mission analysis that we perform. So the climb rate isn't a necessary parameter, but if you're trying to fly and climb or descend in some thousand feet per minute, this is the place you can define it. Next up is the beginning and ending velocities. So again, velbeg is going to be the beginning velocity or the initial velocity of each segment. Vel-end is the ending velocity of each segment. You can see I did a similar thing here. We accelerate to takeoff. During climb, we accelerate to our cruise speed, cruise at 460 knots, descend and slow down to 160 knots. But then since we're going to loiter, we'll climb and speed up again, cruise at 240 knots, and then we'll come in for our approach. We'll slow to 160 knots and then land at 160 knots. And again, I've converted all these to meters per second to fit the requirements of FAST that all the units are in metric. Now you'll notice in the comment, I can either prescribe my speeds in meters per second or as a Mach number. And we'll look at a case like this in the next tutorial, I believe. But there are other mission profiles in FAST that are shipped with the software where you can see there's a mixture of speeds in meters per second and a Mach number. So feel free to follow that convention as needed, because typically you'll get a cruise speed as a Mach number, not as some number of knots. And then lastly, once you define your beginning and ending velocities, you also need to specify the type of velocity. So you can either prescribe a true airspeed, equivalent airspeed, Those are for all the airspeeds that you provide in meters per second. Or you can prescribe a Mach number, which obviously matches up with the Mach number inputs in velbeg and velend. So that is all the information you need to define the mission segments. As you can see, it's pretty straightforward. All you need to do is define the mission targets, how far or how long you want to fly, and then make up your mission as you see fit. And the one nice thing about this is that you can have as many mission IDs as you want, as long as they are increasing. So let's say I wanted to do a design mission followed by a diversion and then a loiter. I could have 3 different missions. I could have the design mission, the diversion, and the loiter. The important thing to note is that you only have 1 cruise segment per mission ID. And the reason that is because we're iterating over the cruise segment length. So if you prescribe 2 cruise segments in a single mission, we don't know how long each one should be. There's too many free variables in that case. So that's just one thing to note. That pretty much wraps up the video. One thing I do want to just let you know beforehand is that you'll notice that all of the variables here are stored in a mission structure. So we have mission.target to store the mission targets, and then mission.all of these to store the information about the mission profile. And if you remember from earlier in the video, we said this all needs to be packaged up and returned to the aircraft structure. So that's what we do at the end of the script here. So make sure that you set aircraft.mission.profile, which is the data substructure that holds everything relating to the mission profile, before you return the aircraft structure back to FAST. So this is a common mistake we sometimes see when people generate their own mission profiles. They list all the segments and the mission IDs, but they forget to store it in the aircraft structure. So please make sure to do that when you're creating your own mission profiles. So with that, we would like to thank you for joining us in this video. We hope you found this useful. And now that you're familiar with the general structure of the mission profiles, what we'll do in the next video is, instead of hard coding one like we did here, we'll show off one that is parametric in nature and uses information from the aircraft structure. So we'd like to thank you for watching, and we'll see you in a later tutorial.